Hi everyone, thanks for watching this video. My name is Gabriel and I work as a senior blockchain engineer for ConsenSys. Today I'm going to be presenting and demoing the Quorum Key Manager. What's the Quorum Key Manager? The Quorum Key Manager is an enterprise solution to manage your private resources. For that I mean secrets, keys, and Ethereum wallets. In order to accomplish that, the Quorum Key Manager is integrated with the most popular Vault engines such as HashiCorp Vault, Azure AKB, and Amazon KMS. Using the Quorum Key Manager HTTP REST API, you can easily handle your secrets, create and import your keys, encrypt and decrypt with them, and sign with your Ethereum wallets. Quorum Key Manager supports many different signing operations, such as the standards of Ethereum transactions, including the latest EIPs like EIP 1559, and also it supports the signing for private transactions like the ones you find in Oracle and Tessera, and different types of transactions and meta transactions. Quorum Key Manager also supports different elliptic curves and signing algorithms for your keys, such as DDSA and BN254, and ECDSA and CEP256. Quorum Key Manager can be used also to proxy your traffic to your JSON RPC nodes in a way that every call which one requests a signing operation is going to be intercepted and signed with the wallets you can find under your vaults connected to the Quorum Key Manager. Quorum Key Manager can be deployed using different methods for authentication, such as TLS mutual authentication, OpenID Connect, API keys, and different levels of authorization as well, using the standards of role-based access control. To work with the Quorum Key Manager, this is the concept you need to get familiar with. So the first one is manifests. Manifests are the YAML formatted files you use to set up your Quorum Key Manager service, in where you're going to include, you're going to define which are going to be your stores, your nodes, and your roles. Stores are the components you are going to use to distribute and encapsulate the access to your private resources. And there are three types of them. One is for secrets, another one for keys, another one for Ethereum wallets. Then you have nodes. The nodes are the JSON RPC nodes where the Quorum Key Manager is going to be proxying the traffic and intercepting the signing operations. Then, after that, once you define the setup of your Quorum Key Manager, you can additionally define which are going to be the authentication support, the method of authentication integrated in the Quorum Key Manager, and which are the authorizations you want to define, the authorization rules you want to define for the Quorum Key Manager. For the authorization, we have a granulated level like resources, which are the secrets, keys, and Ethereum accounts, actions, which are the actions you can use with your resources, so either creation, deleting, and signing, encryption, etc. And the permissions are the joint of the actions and the resources, which are the permissions are the ones need to be included in the user credentials. The roles are the list of permissions you can define, and tenants are an additional protection or restriction of access to your resources, and which one allows you to restrict the visibility of every store or every node under the Quorum Key Manager. So during my presentation, I'm going to be using these links. During the demo, I'm going to present later. I'm going to be using these links. So the first one is the GitHub repository, where the Quorum Key Manager repository is fine and is entirely open source. It can be checked at any time. The official documentation is where everything about the Quorum Key Manager is described and documented. The REST API is the documentation, the Swagger documentation auto-generated for the Quorum Key Manager. Docker Hub, which is where the Quorum Key Manager images are going to be allocated. The HashiCorp Vault plugin is a Quorum HashiCorp Vault plugin. Is the plugin implemented by our teams to support the key operations under the HashiCorp service. And the Quorum Dev Quick Start is a repository where you can find handy scripts to spin up Besu networks and Quorum network in a very quick manner. So now, the demo. The demo is going to be split in 4 parts. The first part is about the Ethereum store. The Ethereum store is going to be presented by connecting our Quorum Key Manager to my AKB service and creating an Ethereum account and use it for signing a regular Ethereum transaction and then sign a type transaction using the same Ethereum account I created before. Then on the second part, I'm going to be connecting my JSON RPC and my Quorum Key Manager to my JSON RPC node and sending a send transaction, and I'm going to validate how that transaction is being intercepted and signed by the Quorum Key Manager using the wallet I previously created in the step before. Then on the third part, I'm going to be introducing the key store. For the key store, I'm now going to be connected to my HashiCorp service, and I'm going to create an EDDSA BN254 key and sign with it and validate the signature I generated using the Quorum Key Manager. And then last is going to be the authorization authentication. So I slightly going to introduce this because it's quite wide the ways the Quorum Key Manager can be set up for this. So I'm going to start the Quorum Key Manager and integrate it with the Auth0 as my certified user. Basically, the tokens are going to be generated by Auth0 and they are going to be validated against Auth0 as well. So I'm going to create two different tokens and I'm going to validate how the demonstrate how the Quorum Key Manager authorize a deny access based on the permissions included in these tokens. And at last of this part of this, the demo, I'm going to be presenting what are the roles, how you can define them in the manifest, and how you can integrate them with your application. So this is all for the slides. So now I'm going to start the demo. Before I start working with the Quorum Key Manager, I would like to introduce the Quorum Key Manager documentation website. So in here you can find useful information about how to set up your Quorum Key Manager service using manifest files to define your stores, nodes, and roles, different concepts you need to understand for the Quorum Key Manager usage, tutorials, and how to start the Quorum Key Manager service. In the Quorum Key Manager service, how to start it is you can see you need to download the Docker Compose files, and then you will need to mount a file from your file system using your manifest file or describing your manifest file, and then starting the Quorum Key Manager. I already did that. So as you see, this is the Docker Compose file I downloaded from the documentation. So the first service I will find in this Docker Compose files is Postgres. Postgres is the database service I'm going to be using for the Quorum Key Manager. Migration, which one is a service, which one is going to run to initialize my database schema, and then the Quorum Key Manager service itself. The Quorum Key Manager service is going to expose the port 8080 and 8081. The 8080 is the one corresponding to my HTTP API, and 8081 is the HTTP endpoints to check the liveness and readiness of the Quorum Key Manager. Here is the environment variable I'm going to use to mount my manifest file from my file system, which one in my environment file points to my manifest demo YAML. This is the demo file, the manifest file I'm going to be using at this part of this first part of the demo. As I mentioned before, I'm going to be explaining the Ethereum store. So I'm going to initialize an Ethereum store connected to my AKB account. For that, I need to be defining my specifications, which one are basically the credentials to my AKB key, AKB service. So I'm going to define my tenant, client ID, the vault name, and the secret. So once I define the secret, which is going to happen in another terminal, I can already initialize my Quorum Key Manager. So to start the Quorum Key Manager, I can run this command over here, and you will see all the services are running. And then as part of the logs, you will see that my manifest file is being loaded successfully, and one Ethereum store is being initialized with the ETH store as an ID. So before I go to Postman, you can go to the API documentation website, where you can download a JSON file containing all the available API keys for the Quorum Key Manager. Once you do that, you can import it inside your Postman, and then you will find the template for all the HTTP calls you can do to the Quorum Key Manager. So for this as a demo, or for this part of the demo, I'm going to be using first the create Ethereum account. As part of the template, I need to define which is my ETH store ID, Ethereum store ID, which one I name it as ETH store, Ethereum. And this is the key ID I'm going to be creating inside AKB, my demo account, let's say. So I send the request. Request is accepted successfully. This is the information about the key I just created with the key ID, the address of my Ethereum wallet, and other information about my key, my wallet, my account. So if I go to Quorum Key, my AKB dashboard, where I list my keys, I will not find it because I have many. So I want to click on one of them, and I'm going to replace the ID by the one I just added. And then you will see the description of the key I just created for my Ethereum wallet, where you can validate that the key I created is the one compatible with Ethereum, which is the SECP250CK. So now the key is created, we can start signing transactions with it, right? So I copy the address, which is the identifier of my Ethereum account, and I'm going to go to Ethereum's sign Ethereum transaction. So again, I'm going to replace my ETH store ID, and then I'm going to replace the address, and then I'm going to sign the transaction. I send the sign transaction call. So this is correspond to the template of my transaction. So let's keep most of it. So I'm going to use this chain ID, this value as my gas limit. This is the data corresponding to, let's say, my smart contract code, ABI encoded data. So the gas price of the network, it could be any value, let's say, depending on the state of the network, of course. And the nonce, I'm going to use number one. So this is correspond to my Ethereum, to my smart contract address, for instance, and then I'm not going to send any value in this transaction. So if I send this request to my Quorum Key Manager, as a response, I will get back the signed raw transaction. So this is the value I could forward to my node to get my transaction mined. So as simple as this, you can sign the transactions using simple APIs. So as I mentioned before, there are different types of transactions. One of them is the one specified in the EIP 712, the sign type data. So sign type data contains more advanced information about meta transactions. So in this will be the template you will find with it. So if you go to the specifications of the EIP, you will see more information related how these transactions should be crafted. But for me, for this demo, I just already prepared some specifications. So this is going to be my message, which correspond to my sender, receipt, and content. And this is going to be the types of my email. And once I fill up my sign type transaction, I'm going to send it to the Quorum Key Manager. Sorry, I need to specify also the gaps of the call, which are the ETH store as the store ID, the address, which can correspond to this one over here, and send it to the Quorum Key Manager. So this corresponds to the sign, to the raw sign transaction of this type data transaction. This can be now forwarded to the chain, as I mentioned before, or it can be used in other use cases as is defined on your application in any case. So this is all about the first part of the ETH store. So as you see, you can find different type of transactions like EA transactions in case you want to sign private transaction for Orion, or you want to sign a message using the standards of the EIP 191, or you can sign a quorum transaction, etc. Right? So once we finish with this, I'm going to go to the part number 2. So I'm going to explain how we could integrate the Quorum Key Manager with my RPC nodes. So for that, I'm going to go again to my manifest files. I'm going to define my node, which is this one. If I can copy it, paste it here. Yeah. Okay. This is the ID of my Besu node. For that, as I mentioned before, I can use the quick start. The quick start to spin up a Besu network quickly. So I already downloaded the repo and I have it over here. So I'm going to start my Besu network. As you see, this is the IDs of my nodes. Meanwhile, I'm going to modify my Docker compose to connect to the network. Okay, the network was I already modified it before, sorry. So I connected to Besu network, and this is for next part of the demo. So I connected to my network for Besu. So once Besu is initialized, it's already done. So I'm going to stop my Quorum Key Manager and run it again using this manifest. Okay, sorry, I'm going to put the secret again. Okay, once I finish with that, I go again and start my Quorum Key Manager service. Now we will see, along with the Ethereum store, a new node was loaded, which is have the identifier Besu node. So now every time I want to do a call I want to proxy a call to this node, I can use the Quorum Key Manager using this ID over here. So I again go to Postman, proxy a call. So this is the template for the proxy call. In this case, I replace the node ID, which is Besu node, and I'm going to send a simple RPC call, which one fetches the information about the block number 1. So I send it, and as you see, I get back the response from the node with the information about the block number 1. So once we validate that the node is connected correctly to the Quorum Key Manager, we can send a signed transaction. Again, we replace the ID, Besu node. And in the body of my request, I'm going to send a send transaction payload. So for that, I already prepared this. Okay, I'm missing the bracket at the beginning. Okay, so for the from, I'm going to use the account I previously defined here. I'm going to send a transaction from this account to this address with this data. I send it. Okay, this is a post request, of course. And as a response, I get back the transaction hash of my transaction. So the transaction is being signed using the Quorum Key Manager based on the address of this account. So you basically perform the signed transaction action under hood, filling up the parameters of your transaction or crafting your transaction, fetching the required information from the node, such as the node, the gas price, etc., and sign it using the key stored in your AKB service. So this is all for the JSON RPC part. So next, I'm going to explain how we could create keys and how the key store works. So for that, again, we go back to our manifest. For this, we are going to be using HashiCorp keys because by default, the AKB doesn't support BN254 and EDDSA keys. So as we implemented inside the HashiCorp plugin, the support for this kind of elliptic curves and signing algorithms, I'm going to be using that, right? So in case you would like to use AKB, you optionally will have the alternative to define a local key, local keys, and then you will need to specify the specifications for your secret storage. So you will find instructions in the documentation website in case you are interested about it. But for this demo, I'm going to focus only on the uses of the HashiCorp plugin or the HashiCorp service using our plugin. So this is HashiCorp service using our plugin settings. So first, I need to initialize my HashiCorp service. For that, I'm going to use the instructions you can find inside our HashiCorp Quorum plugin. So this is the repo where you can find the instructions in the README about how to run a Quorum Key Manager HashiCorp service with our plugin in it in development mode in this case, because I would like to have a hard-coded a fixed token to interact with my service. So if I now go to my manifest, if I go to my terminal first, I initialize my HashiCorp service with the plugin. First, also I need to validate, okay, so I need to connect my Docker Compose to the HashiCorp network. Okay, this is the ID because I prepared it before. So my HashiCorp service is running. I need to check which is the ID of the container. So this is the ID of my container. So HashiCorp is going to be running on port 8200 on this ID inside the network of the Docker Compose network, using this token. This one is the development token. I'm going to use the demo namespace demo, and this is the mounting point where my HashiCorp plugin is going to be mounted. So once this is ready, we don't need the node anymore. So now I can go again to my terminal, stop the Quorum Key Manager, run it again. Okay, store manifest is loaded. Now it's loaded with the HashiCorp keys. And now I can interact with HashiCorp to create new keys. So again, go back to my Postman, and now I go to the keys section, and I got to use the create new key HTTP call. So I going to replace my key, my store ID by the key store. And the ID, this is the ID I'm going to use for my key, demo key, and send it. Okay, this is small mistake in the corpse. It's going to be BN254 instead of 256. And the signing algorithm is going to be the ADDSA. Once I do it, that was quick. So the Quorum Key Manager is going to forward the creation of the key to the HashiCorp service, which one loads our plugin in it, and it's going to allow us to create this kind of keys. So as the key information we get back from the Quorum Key Manager, we find the ID, the public key, which is formatted in BN200, is formatted in B64, and other additional information about the key. So once the key is created, I can sign with it. So now I go to sign random payload. For the sign random payload, I will need to pass again the store ID, this one, and the ID of my key, which is the demo key. And then I'm going to sign this data again. Every information exchanged with the key store is going to be formatted in base 64. So this is the templated data. So I'm going to use this one as a sample. And then once I send the request back, I get the response with the signature of this data, signed by the key I just created in HashiCorp. So this is the key, the signature. So if I would like to validate again, if I got a signature signed by someone I want to verify for, I can also use the verify endpoint, verify key signature, where I can use the same information in it. So again, I will need to define which is the information of the key being used for signing, which is the BN254. This is the same data, I believe. The signing algorithm is the EDDSA. The signature gotten by before is this one, and the public key of the key who signed this data is this one. So if I didn't do any mistake, this will work. Key store. Okay, so I forgot to replace the information about in the request. So now I do that, I get that 200. So if you get that 200, it means that the verification went successfully. So this payload was signed by the key you introduced in the request. So if I do any small change like this, illegal B64, but if I sign it with, if I specify a different key, like this one, fail to sign, I will get a failure response, like fail to verify the signature. Or if the signature itself is being different, it's also the signature doesn't belong to the specified public key. So this is the verification endpoint you can use by the key store to verify that the signatures you obtained are signed by the keys they told you they were signed with. So this is the most basic behavior of the key store. And now, at last, for the Quorum Key Manager demo today, I'm going to be introducing the authorization and authentication. For that, I'm going to, as I mentioned, I'm going to be using Auth0. So I already created an application in my Auth0 account, which is the Quorum Key Manager, where I'm going to create, which I'm going to use to create tokens with. And the one is the same I'm going to use to actually verify my tokens with. So to do that, in the Quorum Key Manager, you will need to specify who are going to be your OpenID Connect issuer. So for that, I'm going to specify the Auth0 is going to be my issuer for my tokens. And in the manifest, I will not need to do any changes. So I'm going to leave the Quorum Key Manager, the HashiCorp keys as my, for this example, and I'm going to use two different tokens. I already generated the tokens for the sake of being faster for this presentation. So the first token is going to be this one, which one contains only permissions for reading keys, and the second one, which is going to contain permissions for reading and writing keys and signing with them. So if I now go to the Quorum Key Manager, stop it, start it again with the new settings, which one includes my OpenID Connect issuer, which one is specifying environment variables on my Docker Compose. So I run it again. I will see in the logs now that the OpenID Connect Authenticator is enabled. So the requests going to my Quorum Key Manager are going to now be need to be authenticated and authorized. So if I now again trying to send a request for signing the same payload as I did before with no credentials in my request, I'm going to get the user is not authorized to perform this operation as a response instead of their successful response. So if I would like to get a successful response, I will need to provide the right credentials to it. So for that, I will need to use the second token I showed to you, which is the one containing the signing permissions. So using this token, I just paste it in my Postman. I send the request, and then I again obtain the signature of the sign data request I sent to Quorum Key Manager. If my user doesn't have the right permissions included in the token, as I'm going to demonstrate now, this is the one only including the read permissions for the keys. I send it again. It's as a response I will get that the user is not authorized to perform this operation. So at last, for the authorization authentication, in case you don't want to use any identity provider like Auth0, using the Quorum Key Manager, you can also specify the roles on your own. So for that, on the manifest, you can include this format over here, where you can specify the ID of your role and the list of permissions associated to it. The same for the guest in this case and the signer. So along with your credentials, you can specify the roles on a specific path of your credentials. In case of the GWTs, in case of TLS mutual authentication, other ways to specify the roles is defined. You can find it in the documentation website. But in here, you can easily integrate the roles in the Quorum Key Manager and send requests with them. So this was all about the Quorum Key Manager. I hope that you like it, and in future versions of the Quorum Key Manager, we will be doing more demos and presenting new cool features of this product. Thanks for watching us. If you have any questions, please find our email contact in our Quorum Key Manager repository. Thanks.